Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome back to the podcast. In today's episode, we're going to be talking about what difference it makes to the atomic model when we introduce basic quantum mechanics. This is a concept that gets introduced into your chemistry studies, into your education, when you're going from a beginner's chemistry level into a more advanced level. So, for example, going to advanced level chemistry when you previously studied GCSE. So what differences do we start seeing in the model when we introduce basic quantum mechanics? Well, our model changes in as much as we see a difference in the shape of the atomic model and the shape of atoms. You also see how it affects the shape of the periodic table. Before we considered the concept of quantum mechanics, we considered that atoms just have shells of electrons, but we're going to see that they have subshells within those shells as well. Not only that, but those subshells are made up of orbitals, and we'll talk about what orbitals are and their shape and the effect that has on bonding. Previously, you will have considered a basic model of the atomic shape, almost a two-dimensional model with a nucleus and shells of electrons orbiting around that nucleus in a two-dimensional pattern, a bit like a solar system. We're going to see that's very much a simplification, an oversimplification. It just doesn't work for A-level chemistry and for the periodic table either. For example, we're going to see that there are different energy levels within each shell as well. So those different subshells, those different orbitals, don't all have exactly the same energy as each other. So previously we considered a shell of electrons. All those electrons in that shell have exactly the same energy. And actually it's divided up so that the different subshells, the different orbitals, have different energy levels. We'll also consider how quantum mechanics affects the shape of the periodic table. In the model we've studied so far, we talked about the first shell within an atom has a capacity of 2 electrons, and the second, third, and all subsequent shells having a capacity of 8 electrons. And if you look at the periodic table, that works fine for the first 20 elements, but then after that, you'll see that periods across the periodic table have more than 8 elements. It follows that some shells must have a capacity of more than 8 electrons. They have a predictable capacity, as we'll see, and that's what makes the periodic table have the shape it does. What we'll discover is that each subsequent shell has a greater capacity for the number of electrons than the previous shell. The first shell has a capacity for 2 electrons, the second shell for 8, the third for 18, and the fourth shell has more, and so on. And we'll look even closer at those shells as well. So in the model you've studied so far, all the electrons within each shell are doing the same thing as each other. They have the same energy, they're doing the same movement, they're orbiting in the same way as each other. And we're going to see that it's a bit more complicated than that. There is orbitals and subshells within each shell, and the number and type of those depends on exactly which electron shell you're looking at. And our studies of this model will certainly look into that as well. You'll see slightly different energy levels for those different subshells within electron shells. Not only that, we'll see that the subshells are made up of orbitals that have a capacity of 2 electrons each. Subshells therefore have a capacity of an even number of electrons. There are a different number of orbitals within each subshell. The simplest subshell has just 1 orbital, so that has a capacity of 2 electrons. Subsequent subshells have 3 or 5 or more orbitals, so have a capacity of 6 or 10 or more electrons. And don't worry if that sounds very complicated, confusing at the moment. It will become apparent when you study this in more detail. And those different subshells, those different orbital types, they have 3-dimensional shape within the atom space, and that is one of the things that affects the shape and bonding of molecules. When atoms bond to each other and form molecules, the shape and relative positions of those orbitals of adjacent atoms makes a big difference to the shape of the outcoming molecule and the bond angles within those molecules. All this is happening because we're starting to consider some actually very basic quantum mechanics. It's not that complicated. The name of it sounds a lot more complicated than it really is. When you get to this level, when we introduce quantum mechanics, we'll introduce and consider 4 quantum numbers that are related to the electrons within each atom. Those quantum numbers correspond to certain characteristics of the atom. For example, one of them is about which energy level, which shell the electron sits in. Other quantum numbers refer to the orbital type that the electron is in. And there is one that refers to a property we haven't introduced yet called spin. And we'll go into more detail of those in another episode. So in summary, today we've talked about the fact that previously our atomic model did not include any quantum mechanics at all. And now we're going to introduce quantum mechanics and the use of 4 quantum numbers. We talked about those quantum numbers being related to the electrons that are in an atom. We inferred that those quantum numbers tell us something about the electron, its energy level, and more. And all those things have a profound effect on our quantum model. It turns the physical model of atoms into a much more 3D shape. And it also explains very much the shape of the periodic table and why there isn't a maximum of 8 elements across the periodic table. We also said this affects the way atoms bond and become molecules, and the shape and bond angles within those molecules too. So before I go, I do have a PDF you can download on this topic. To get that, just go to chemistrymadesimple.net/2. That's the number 2. I'll also put a link to that in the show notes. So no doubt you'll have more questions on this topic, or maybe you'd like to know how to work with me more closely. And if you want to do that, you can get in touch with me. The best place to do that is on my Patreon community at patreon.com/chemistrymadesimple. Again, there's a link in the show notes for that. I do look forward to hearing from you, to hear more of your questions, and to be able to work more closely with you to help you. So that brings us to the end of this episode. I'll be following up this episode with more episodes that go into more details of what we've talked about today. So don't forget to hit subscribe so that you receive those too. Look forward to speaking to you then. Have a good day. Goodbye. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.